Hello friends, welcome to my YouTube channel. Thank you so much for subscribing, watching my videos. I'm sure it is adding value to your knowledge. Today's topic is understanding of static pressure in HVAC. Very important topic. Most of the time we ignore it and then we find problems when the system gets commissioned. So my name is Ajaz Kazi. Let us look at about static pressure. Static pressure, which is SP, is a critical factor in HVAC system because it influences airflow efficiency and the overall system efficiency. If the static is high, your airflow get decreased. If static is high, your motor consumption goes up, efficiency comes down, overall efficiency of the systems comes down. So we need to understand this phenomena, this concept very well. Yeah, what is static? It is a system resistance, right? When I want to pull air from that air by this fan over here, I must be able to pull that air, and there could be some resistance to pulling it out. If I want to send air from here to here, minimum resistance. If I add duct and get exhaust points from different areas, different pressure, because you got a lot of elements in between. Every element has its own resistance. So it's the pressure difference between supply and return sides of a HVAC system. Most importantly, I know what is the static of my fan, internal static, or my HU, where I got filters, my fans, right, and some element of my fan casing, other thing. But it is very important to understand what is the external static pressure, right, which is very important because that is in this outside your component. This is calculated as the pressure difference between supply and return side, considering the external factors like ducts, fittings, terminals. The duct, the kind of duct, the friction of the duct, the elbows in the duct, the outlets in the duct, the grills in the duct, they play an important role while calculating the external static pressure. What is supply static pressure? This is the pressure difference between supply fan and the duct systems. What is the return static pressure? This is the pressure difference between return duct systems and the return fan inlet, right? So get these things very clear. We generally face higher static pressure. This leads to reduced airflow. The air quantity is reduced. As I said, increase the energy consumption because the resistance is high. You have to go for higher motor, higher fan, and it also creates system imbalances. So this is a very important phenomena which we need to understand. How do we optimize the return static pressure? Have a proper duct sizing. You can't have improper duct sizing which can create more resistance, right? Reduce fitting in the ducts. Try to get a smoother layout of a duct. Balance the airflow while doing the adjustment. Adjust dampers such that you get a proper flow from supply as well as return. Upgrade if they still have problems, increase or add or increase the capacity of return air fans, right? Or if you are going to supply and if you are not able to get the return, then you have to create return paths so that the return comes back to the and it doesn't create a static or resistance. So you have to create return air paths, increase the size of the return air openings, try to find the return comes back. This is one of the major challenges you find because you don't get return, right? Regular cleaning of the filters because it will create strain on the system. Regular cleaning of coils, ducts. This will help you to optimize your return air. This will be able to reduce your high return static pressure. Very important. What are the best practices? Consider correct ESP while designing, right? We can't go on changing the motors and fan later. Regular measurement of static pressure, have the pressure sensors, always monitor. That also can give you alerts what is going wrong. Ensure proper balancing, proper commissioning, and proper cleaning of system components like coils, filters, ducts, right? Hope you got some clarity on static pressure. Please subscribe my channel, follow me on YouTube, Facebook, LinkedIn, hvacsystem.com.